Whoop, whoop. Hello, everyone, and welcome to the Energy Resilience Lab. Our lab is dedicated to giving you the knowledge, skills, and the encouragement that you need to become energy independent and energy resilient. Today, another week has transpired, and it's time to throw down more information. Okay, guys? So I want to teach you guys a little bit about the electrical grid. So there's something called the base load, or the base power supply, that the utilities need to supply to keep the whole system operating at all times. And what that is a constant amount of power, or kind of the minimum amount of power 24/7 that is utilized in a large area. So it could be a few states, it could be half of the country, it could be the whole center of the country. It just depends on how the transmission lines are laid out. But it is the total sum of energy that's being used on the grid at the same time. So if you guys want to kind of visualize it, just think of 300 million people thinking, hey, I got to plug in my phone. So they all plug in their phone at the same time. And each of those phones starts taking 18 watts. If it's fast charging, an iPhone or a Android phone, or larger loads like everyone gets home in their Tesla and they all plug it into the grid and they start consuming 12 kilowatt at every home in this area. So this can be a huge amount of power, and the base load is just something that always has to happen, and that is kind of the lower limit of what the utilities need to provide. And so that base load is usually provided by a very large scale generation facility. So it was coal fired in the past, or natural gas fired more recently. But there's also nuclear and other forms of electricity. And then in addition to that, there's peakers. So you have this base load, and that's the amount of power that's needed for everyone. And then as that load increases, there needs to be other assets that come online to take up that power so that the system can keep operating and keep the voltages and everything regulated across the whole system. So those are kind of the different systems that exist. In addition to that, you have all the renewables that are coming online. And if you have renewables without energy storage, then they are very, very intermittent. So the sun goes down, a cloud comes over, it will drop by 90%, the production will. The wind turbines, when the wind stops, they go to zero. And they could stop for 5 days, and then they could operate for 30 days, but it's not known. And so those generation facilities come online and they add energy which disrupts the flow through the whole system. And so the whole system has to react, and they have to tone down production and drop different generation facilities to make sure that they're not overproducing. And in addition to that, there's a lot of municipal generation. So in my area in the west, there's a lot of hydro turbines. And so these are just dams that are there operating, consuming the water that's going down the river, and generating power from that. And what that does is it just adds a little bit of power to the base load. So if there's 1 megawatt, like 1,000 1 megawatt hydro turbines in a region, then that would be 1 gigawatt power that's getting produced by those. And they are very consistent, and they can just output that amount of power and just keep doing it until you have off years like we've had in the past with droughts and things. So that's kind of how the power system works in the grid. And once you add batteries to a system, the renewables then can become more of a power source that's more consistent. So if you look at like wind turbines, they'll be spinning for 5 days and they may produce 1 megawatt. And so you've got 5 megawatt hours of storage there, and you can take that in and then distribute it during the downtime. So you'll just export the average amount of power that's produced over the duty cycle of the wind. And that just levels everything out, and it makes it a lot easier to model. And so what kind of brought this up is here in the West, they're starting to look into micro nuclear little power plants, micro nuclear power, and they're modular systems, and you can stack them together to get different power ratings. So I believe it's UAMPS here in Utah, I think, in the West. I think they cover lots of states, but they have 50 or so municipalities that are investing in micro nuclear. And what that's going to provide is 465 megawatts of power continuous. And in the recent months, there's been a lot of announcements of utilities shutting down and decommissioning natural gas production generation facilities. And that can be a little disconcerting because they are the ones that are providing the base load. And so as they keep decommissioning those, we need something to take its place. And so micronuclear is one of them, and it's amazing. So they're going to be putting together 6 modular micronuclear clean generation facilities. And that system will be able to do a 0.5 gigawatt power. Essentially, it's 465 megawatt power. And that will power essentially, I think it's between 50 and 70 municipalities. So 50 to 70 cities will be able to will that power across the transmission and receive it at their location. And it's just another way that the utilities are kind of following the transition to go to more clean opportunities, but also to still provide the base load so we can have consistent power and not have it drop out or not have brownouts and other things that could be caused by a lot of renewables on the network. So kudos to them. They're just jumping through the initial hoops of requirements to be able to commission the micro nuclear system. But that's kudos to them. They're doing a lot of great work, and I need to look into a little bit more, so I'll do that to see how it is cleaner than other nuclear facilities that are in production today. But it does mitigate the risk of a large meltdown. So if you have a small breakdown of one of these, it's only a 80 megawatt system, so pretty small system that could melt down, and they have a lot of redundancy to protect from any of that spilling, and they can control the temperatures better because it isn't this huge reaction that has to be shut down in the event that there's a failure. So it's amazing. Kudos to them. I'm glad people are looking into that. I reported on California. They had a hydrogen generation facility with batteries in, I think it was Pacific Gas and Electric in California. There's just a lot of amazing new technologies coming online, and I just want to keep you guys up to date. So thank you guys for checking in. You guys, I love you guys. Keep liking and subscribing, and I'll keep bringing the goods, all right? So go team. We'll see you guys next time. Never surrender. See ya.